Metallic bonding. This chapter explains actually the bonding present inside a metal, and the regular structure of a metal is that all are atoms of similar type in a particular metal, and they have many electrons delocalized, and these electrons are actually from the outer shell of each atom. And when the electrons of outer shell of each atom is just moving into the structure, the atoms become positive ions. Now look at this diagram, everyone. I magnify this diagram for you. Look at this diagram. These were atoms of the metals, but the electrons from the outer shell are not fixed into the outer shell. Rather, these electrons are inside the structure. They come out from the outer shell and they are moving into the structure. And those neutral atoms, due to the lack of electrons, they become positive ions. And these electrons are moving throughout the structure. Look at this structure. The structure contains array of positive ions with some delocalized electrons. So the structure of metals, but we can write the structure of metals. I want everyone to write. It has array of positive ions with sea of electrons, it can be said, or delocalized electrons present in its structure. So these atoms, the structure has any metal, the structure has array of positive ions and sea of electrons or delocalized electrons present in its structure. These electrons are negatively charged and the atoms are positively charged. So there is an electrostatic force of attraction present between the positive ions and negative delocalized electrons. So what I can write, the ions are positively charged, positively charged and delocalized electrons are negatively charged, and there is electrostatic force of attraction between the positively charged ions and negative delocalized. Yes, please. It's very important. This is the structure of metal. If you know once, it's very important. Please copy it.
Okay.
It's very important. The structure of metals. There are positive ions and there are many delocalized electrons. The ions are positively charged and the electrons are negatively charged. And there is a strong electrostatic force of attraction present between the positive ions and delocalized electrons. It's very important, the structure of metal. And this diagram is very important. You must learn how to draw this diagram. This diagram is very important for IGCSE examination, O levels examination. It's very important diagram for O levels examination. Now, students, look at question number, now look at this page number 99. metallic bonding that I already said, that is force of attraction present between electrostatic attraction between positive ions and negative electrons. Look at this force of attraction. It's called metallic bonding. This force of attraction is called metallic bonding. The force of attraction between positive ions and delocalized electrons. So let us underline. Metallic bonding is actually the electrostatic force of attraction between positive ion and delocalized electrons. This holds the structure together. Very important point, very, very important point. And this is the metallic bonding. And this diagram, look at this diagram. And metals have also giant structure. And different metals have different arrangement of ions in their lattice. A particular arrangement of piece of many atoms or ions is called lattice. And metals are in atomic form. Atoms become ions when the electrons are not there. Electrons are just outside the atom, then it forms ions. As the electrons are outside, it is indicating that it has lack of electrons, so it forms positive ions. Now, group 1 metal atoms, each atom lose 1 electron from their outer shell, so they form 1 plus ion. And group 2 elements, group 2 metal elements, they lose, each of them lose 2 electrons from their outer shell and they form 2 plus ions. And similarly, group 3 elements in group 3, they form 3 plus ions as they lose 3 electrons from their outer shell, and so on. Physical properties of metal. Look at this. This is the physical properties of metals. Metals are generally high. They have high melting and boiling points, high density. They have sea of electrons. They conduct electricity. Metals conduct electricity because they have free of electrons. Sea of electrons which can move and conduct electricity. This is the point here, that metals conduct electricity. So I just underline. They have delocalized electrons throughout the structure or free of sea of electrons, which electrons can move throughout the structure to conduct electricity. So when there is a connection given, a power supply is given, positive and negative terminal, the electrons are being attracted by the positive terminals of the voltage supply and it starts moving towards the voltage supply. And when electrons move, you know that the flow of electrons is called the charge is moving, and flow of charge, it is actually current. So flow of electrons, it forms actually current. And this is the way that metals conduct electricity. And ionic compounds, they conduct electricity by using their ions. When ions are free to move, they conduct electricity. And ionic compounds have ions, free ions when they are molten or they form aqueous solution. What does aqueous solution mean? Ionic compounds dissolve into water and form aqueous solution. So you have to remember these two different things, that ionic compounds conduct electricity when they are molten or in aqueous solution by using their free ions. And metals conduct electricity by using their free electrons. And similarity, there is a similarity with metal and graphite. Graphite also conducts electricity by using free electrons in its structure. As you know, that each carbon in graphite has covalent bond with 3 other carbon atoms. So 1 electron for each carbon atom is free. That electron is responsible to conduct electricity for graphite. And opposite is true for diamond. Diamond does not conduct electricity because diamond does not have any free electron, as each carbon is covalently bonded with 4 other carbon atoms. All atoms are covalently bonded. All electrons are shared pair of electrons, and that's why diamond does not conduct electricity at all. So the gist point is that you have to remember, metals conduct electricity, graphite conducts electricity, diamond does not conduct electricity, and ionic compounds conduct electricity when molten or in aqueous solution. Ionic compounds do not conduct electricity when they are in solid form. All right. So I just let you to look at this structure a bit. I give you 1 minute. I excuse you 1 minute. Please read these lines and look at the structure. I remain silent for 1 minute. So it was about metals, that metals conduct electricity. Now I move forward some other properties of metals. One property, one of the important properties in metal is malleability. Metals are malleable. Look at this. Metals are malleable. What does it mean? It means that when the metals are hammered, they can be given into shape. When hammered, metals can be given into any shape. This is called malleability. And this property is responsible because the metals, any metal, it has layers of positive ions and the layers slide over each other. Look at this, what I underlined. Any metal has layers of positive ions and the layers slide over each other. Any metal has layers of positive ions and the layers slide over each other. When a force is applied, the layers slide, and what we see that a metal is malleable. Look at this, a force is given here. This is the force. A force is given here. This one. This is the similar thing. This is the similar thing. That's why a metal is also called ductile. So what does the word ductile means? That a metal can be drawn into wires. Ductile means a metal can be drawn into wires. Now, just right now, if you look at the ceiling of your room, you see that is the fan is moving and the wire connected with the fan, you can see the wires are made actually by metal, mainly copper. Copper is one kind of metal. So the wires are made by metal, any wire, and wires can be made by metal because of this property of metal, ductile. It can be drawn into wires. And another important property is malleable, and that's why we can make large sheets and kitchen utensils and different other things by using metals, because it has malleability property. You understand? So this is the thing, the positive ions and delocalized electrons. Look at this. When there is a force given, it bends, and this bending property, this is the malleability property. So very important thing we learned today. I repeat once again the gist points we read today. Metals, the structure of metals. Metals have array of positive ions, and there are many electrons free from each atom, from the outer shell of each atom. These electrons are called sea of electrons or delocalized electrons, and these electrons can move throughout the structure, and that's why metals conduct electricity. And so metal has the metallic bonding. The definition of metallic bonding is that the electrostatic force of attraction between positive metal ions and negative delocalized electrons. This is the electrostatic force of attraction. So metal structure gone. Why does it conduct electricity? This is gone. And metals, definitely metals have generally high melting and boiling point. Metals have high melting and boiling point. Some metals are so reactive that they even react with water. For example, sodium, potassium, lithium, rubidium, cesium, francium. Even rubidium, cesium, francium, they catch fire with water. They're so reactive, so reactive that they catch fire with water. Any metal, when it reacts with oxygen, water, any metal, when such as sodium, potassium, calcium, zinc, when they react with water, they form metal hydroxide and hydrogen gas. Metals which are less reactive than hydrogen, such as copper, cannot react with water. That's why copper is very good to make things like as water pipes, as copper does not react with water. Even copper does not react with acid, as copper is less reactive than hydrogen. Then we read two other properties of metals, which are malleability and ductility. Malleable means metals can be hammered and given into any shape, and ductile or ductility property indicates that metals can be drawn into wires. Metals can be drawn into wires. So these things are very important. And we have read that group 1 metals, they are called group 1 metals because they have one electron in their outer shell. Group 2 metals, they have 2 electrons in their outer shell, and group 3 metals, they have 3 electrons in their outer shell, and so on.